In 6.6.18, we're given this information for the number of people that have sleepwalked. So if we're assuming that 29.4% of the population have sleepwalked, that's our P. So P is going to be 0.294. Q would be 1 minus that. So 1 minus 0.294 gives me 0.706. And we're going to look at a case of 1,454 adults. So that's going to be our N. And we want to find the probability that more than 438 of them have sleepwalked. And then we're going to do some kind of assuming if we're going to assume that 29.4% is correct, or looking at this sample, maybe that if it's significantly high or significantly different, maybe that would suggest something different of this population rate of 29% have sleepwalked. So if we assume the 29.4% is correct, what's the probability that in this sample more than 438 people have sleepwalked? We're going to go to our normal distribution and we're going to find the mean and standard deviation, and we're going to take in account for the continuity factor of looking at 438. We want to look at greater than 438, so we're going to have to subtract 0.5 from 438 to get a more accurate view. So their x value is 437.5, and we need to find our mean and standard deviation, which can be done. Mean is n times p, so 0.294 times 1454, that's going to say 427.476 is our mean. Our standard deviation is going to be the square root of n times p times q. So plugging those numbers into my calculator, 0.706 times 0.294 gives me 17.372335, and I'm going to compute that. So I'm getting this number here. I'm going to round. Looks like I'm going to round up, so rounding this to this number. And then I'm going to make some kind of information if this is significantly high. So the results, is it significantly high? So first off, we can answer the probability of this event is greater than the probability of the cutoff of significant events. So is it significantly high? No. It's greater than the cutoff that tells us if it's significantly high or not. If it was less than 0.05, the answer would be yes, because it's less than the probability for the corresponding significant event. So then it's not significantly high, so it is strong evidence to support the. So these get a little tricky because you got to really be careful when you read them. So the results are not significantly high, so it's strong evidence to support the assumed rate. If they were significantly high, then it would be strong evidence against assuming the rate. And let's see if I am horrible at reading these. It is not significantly high, supporting again, really tricky here. It is not significantly high, so it is not strong evidence against the assumption rate, supporting the assumption rate. So you got to be careful reading these. I always just kind of rule out the main ones, and then you have to be careful with the words. So hopefully that helped.